Hi folks, today we're going to focus on finding the type and number of solutions. And here's a real quick fact for you. The number of solutions of a polynomial is equal to the degree of the polynomial. So if we go back and think about what does degree mean, degree of a polynomial is just the biggest exponent, which is right here. So make sure that it's in order so we can find that. So this is degree 3, which means that we can go ahead and expect to have 3 solutions. All right, so focusing on this next one, notice that things are a little bit out of order, but all we really need to do is look for that biggest exponent, which is right here, x to the 4th. So with this, we can expect to have 4 solutions. Now, they might not all be real solutions, but, and some of them might be repeat solutions, but we can expect to have 4 solutions in that. Here, we're going to determine how we can find which type of solutions to expect, and it's called Descartes' rule of signs. So all we're really looking for is how many sign changes are happening. First off, how many sign changes are happening with just the f of x. So here's an example right here. F of x equals x to the 6th minus 2x to the 5th plus 3x to the 4th minus 10x to the 3rd minus 6x squared minus 8x minus 8. I know it's a lot, but we're just looking for sign changes right now. So right here, where we have these red arrows, here it's going from positive to a negative, and then it goes from a negative to a positive, and then from a positive to a negative. Those are sign changes, and then it just stays negative the rest of the way out. So what we have going on here is basically 3 sign changes. 1, 2, 3. So when f of x has 3 sign changes, then we can expect to have 3 positive zeros. But it could also have less than this by an even number. So it could also have 1 real solution. So right down here in this chart, it tells us it has 3 positive real zeros, or it could have 1. It goes down by an even number. Now, the next thing that we look at is the number of negative real zeros. And the negative real zeros is the sign change of f of negative x. So we need to put in f of negative x, and we need to make these sign changes happen. Okay, so notice we plug in negative x for x right here. Okay, so negative x to the 6th is still x to the 6th. Negative x to the 5th times negative 2 would be plus 2x to the 5th. And on and on and on. So you can see what happens with your sign changes. Now, right here, we're going from positive to negative, negative to positive, positive to negative. So there again, we're having 3 sign changes. From this point, it's all positive. So we have no sign changes until we get here. So when we have those 3 sign changes, that means we have 3 negative real zeros. And it could also be less than that by an even number once again. So it could be 3 or 1. Now the number of imaginary zeros is going to depend on what happens with these 2 parts, with the positive and negative. We know that since it's an x to the 6th, we should expect 6 solutions. So 3 plus 3 is 6, which means no imaginaries. But the negatives could go down by 2. So we could have 3 positive and only 1 negative, which leaves room for 2 imaginary zeros, which gives us a total of 6. Or we could have 1 positive and 3 negatives, which leaves room for 2 imaginary zeros. We could have 1 and 1, 1 positive, 1 negative, which leaves room for 4 imaginary zeros. No matter what, these 3 columns need to add up to your total possible. So here we're going to see a couple of examples that work on just determining number of positive, negative, and imaginary zeros. So this first one right here, f of x equals x cubed plus 2x minus 11, we're just going to look at sign changes that are occurring right here. This is f of positive x. So we go from a positive to a positive. That's not a sign change. But then we have from positive to negative. So there is a sign change right there, which means that we're going to have a possibility of 1 positive solution. Now we need to take a look at f of negative x to figure out how many possible negative we have. So f of negative x is negative x to the third plus 2 times negative x minus 11. So f of negative x, here we still have negative x to the third. Here we're going to have minus 2x. Here we have minus 11. Now if we look at our sign changes here, it's negative the whole way through, which means that we will not have a negative solution in this. So there will be no negative solutions. Since we are expecting to have 3 possible answers and only one of them is going to be positive, that means that the other 2 will be imaginary. So we can expect 2 imaginary solutions. And that's really all we're looking for on this. How many positive solutions are we going to get? How many negative solutions are we going to get? And how many imaginary solutions are we going to get? That's it. So going over here to the next one, we first look at g of x sign changes. So how many positives can we expect? How many sign changes are there? We have a sign change from positive to negative, another from negative to positive, from positive to negative, and negative to positive. So right there, we can expect a possible of 4 positive solutions. But remember, these go down by 2s. So we could possibly get 2 positive solutions, or we could get 0 positive solutions. I know it's frustrating, but those are the possibilities. At least we have an idea of where we can look. Now we focus our attention on the negatives. How many negatives should we expect? And to find the negatives, we'd find g of negative x. So we have 2 times negative x to the 4th minus 8 times negative x cubed plus 6 times negative x squared minus 3 times negative x plus 1. So now we got to take a look at all those sign changes for g of negative x. We need to do the math on that. So negative x to the 4th becomes positive x to the 4th, so we'll have 2x to the 4th. Negative x to the 3rd is still negative x to the 3rd, but then it's multiplied to negative 8, so it's going to be positive 8x to the 3rd. Here is going to be positive 6x squared. This will be positive 3x plus 1. So with this, it's positive the whole way through. So we're not going to get any negative responses. So no negative zeros. So now, since we are expecting to have 4 solutions, and with positive we could have 4 or 2 or 0, and with no negatives, then we can also expect to have, with our imaginary solutions, 4 or 2 or 0. And that's what we're looking for. How many possibles to expect? 4 or 2 or 0 positives, no negatives, and 4 or 2 or 0 imaginary solutions. All right, you're going to need to practice this. Make sure you get the hang of it. So your assignment is on page 383, numbers 3 through 8, and 34 through 41. Best of luck to you. We'll see you in class.